Thanks everyone for joining early. We'll wait till the full hour to get officially started. But yeah, thanks so much, and feel free to ask already questions in the chat. Tell us what you're here to learn about, what gets you especially excited about 3.8, and as said, feel free to ask any questions. Hey, Chris. All right, one more minute to go. Okay. We still there are a lot of people pouring in, so let's wait for 1 or 2 more minutes. I mean, it's not even full hour by now. Chris also connected his audio, and so we should be good to go almost.
Hello.
Hello, Chris. As the viewer numbers are still rising, I would suggest let's wait for 30 more seconds and then get it officially started. As said, welcome everyone. Thanks for getting up early, staying up late, depending on which time zone you're in. So for example, Chris and I, we are currently split between Berlin, myself, and Chris is over in Florida. In other circumstances, I'm over in San Francisco, Chris is over in Florida, so I think we're covering quite a range of time zones here. So feel free to also write in the chat where you're joining in from. And as said, like also what actually gets you excited about the ArangoDB 3.8 release. Also, what are your wishes for 3.9? So feel free to put any of this in the chat, or also hit us up on Slack or any other medium. With that, I would actually say this is probably a good spot to get started. So I would say let's officially kick it off. Recording is on, that's great. And welcome to our webinar on 3.8. So ArangoDB 3.8 analytics at scale. We are very excited about this release. The short disclaimer is it's not yet fully released, but we'll come to that in a second. Maybe just briefly for those of you who are new to ArangoDB, what is ArangoDB actually? So if I had to explain ArangoDB, I would say at its core, it's a scalable graph database. So we have a lot of features allowing you to scale out to really large clusters. So some of our larger deployments are running 40+ nodes in terms of graph deployments, which if you compare it to other graph databases is pretty big. But this is actually not all. So I think the core piece of that is that we can, leveraging the scalable graph technology, also enable other data models such as document, key value, and obviously graph. We'll see we are also supporting, especially with 3.8, also some time series functionality. So basically, graph is not just that connector in terms of like a graph, but also in terms of different technologies. And thereby ArangoDB actually allows you to write a single so-called AQL, ArangoDB query language query, and then query across graph, document, and key value within a single query. There are even advanced query processing capabilities such as Arango search, imagine like a full text search and retrieval engine, but being built into the system. We have our iterative graph and processing framework leveraging Kriegel. And we have our ML and analytics stack, Arango ML. And again, all of this is really combined within one database engine. You don't have to worry about keeping data consistent between different data stores, and also you can address all of that from within one query. All of that, of course, wouldn't help if you couldn't easily deploy it. This is actually how I got to know ArangoDB, because I helped them integrate their first Mesos and first Kubernetes integration. Very early on, was collaborating with the container orchestration tools. So we have a very mature, also open source Kubernetes operator, and we also have a managed service if you really don't want to worry about running ArangoDB yourself. So having that said, who are we talking about ArangoDB? So I'm Jörg, I'm the VP of Engineering / CTO here at ArangoDB. And basically my entire career has been database systems, large scale distributed systems. So started out with my Ph.D. in distributed database systems, moved over to SAP to work on HANA, then moved to San Francisco to work as an early employee at Mesosphere, building up this large-scale distributed container orchestration systems and a lot of data machine learning applications on top. And now I'm pretty happy that at ArangoDB, I can combine all those passions, database systems, large-scale distributed systems, a bit of machine learning, all within one role. And with me today is Chris. And many in our community will actually know Chris. He has done tons of videos, tons of great tutorials. But Chris, do you briefly want to introduce yourself?
Sure, yeah. My name is Chris Woodward. I'm the developer relations engineer here, and I'm also on the machine learning team with Jörg. And I just have a background in tech from everything inside and out with development and administration. And I've gotten to take that to Arango to help with the learning side of the content. And then also help with some of the development projects and things like that. But yeah, my primary focus here is with the ML team, and then in general, just trying to figure out better ways for people to get started with ArangoDB and trying to find areas that seem either hard to pick up or just use in general and get that feedback back to the developers. Or create new content for it. So if you come across anything like that, I'm definitely the person to reach out to, where if you're just feeling like you're having a tough time or don't have a concept, I might not be able to immediately answer, but that's the sort of stuff that gets me ideas for new training tutorials, that sort of content.
Thanks, Chris. So let's start talking about ArangoDB 3.8. So the theme is kind of analytics at scale, and there are a lot of features in 3.8. It took us a long time. A lot of time also has gone into QA and really scalability testing, but a bit more to that later. But let's kind of start with that theme or kind of like core features. So on the one hand, we got our Aql Window Operations. And you might know that from relational database systems, it actually allows you to operate over a range of values and, for example, aggregate over it and then return one output, one average per row you're seeing in your input data. So basically, you're shifting a window over your data set. We got weighted traversals on the graph side. So basically allowing for more advanced graph traversals and especially interesting combinations when you, for example, need to do a k-shortest path query plus some filtering on top. Weighted traversal will actually be your friend as they will allow for very efficient implementations. Then on the other hand, as mentioned, we got Arango Search, and also Arango Search, our full text search engine, added a lot of new features to 3.8. So on the one hand, we got the capability for pipeline analyzers. This is super cool because it allows you to basically compose analyzer pipelines. So we'll see a bit more in detail. If right now you don't know what an analyzer is, don't worry. But basically, by allowing to compose them, it makes it a lot easier to build pipelines and to really construct it out of like smaller analyzers. As said, we'll see some examples here. And the other big field on the search side is the geo support on search. Also to be able to leverage geo functionality from within views and also the new geo analyzers. So ArangoDB has supported geo capabilities for I want to say 3 to 4 years, but would actually have to look up when we released that on the GeoJSON side, and now we are adding this native support also to the search capabilities, making it very easy to combine both those fields. So disclaimer, or kind of the elephant in the room, you might have noticed we call this a preview webinar. ArangoDB 3.8 originally was to be released today. We decided to push it to the first week of July, simply because of we discovered some scalability, some performance during QA, where also we got feedback from our community, from our customers for the RCs. So we decided to push it to the first week of July, but still felt it's very valuable to share the insights in this webinar. There are not going to be any feature changes. It's basically about scalability and smaller bug fixes for now, which have been discovered during QA. Partially also by, as said, by our community. So the RCs, they are public. Feel free to grab current RC is RC2. So always very happy to get community feedback here. So let's dive into the features in a bit more detail. So as mentioned, we got the window operations, and window operations, I would say it's aggregation over related rows. And we'll come to why we actually call that rows, because that might surprise you. We are not a relational database system. So usually what we talk about are collections or documents or graphs. But in this case, we discussed that actually quite a bit, but we decided to also refer to rows, for example, in the documentation. The kind of key part is you can aggregate over a series of values. So for example, there can be anything. There can be a number of results being returned from another query. So for example, here observations, if this is the result of a subquery, it can be just a collection of documents. And then you want to aggregate over a certain number of rows, or if this is a collection of documents in this case. What window operations allow you, similar as in SQL, is that you can produce certain outputs per observation in this case. So for example, in this case, in the sample query here, we would do a number of things. So we would go through each of the observations, and for each of the observations, we would basically return what we see here on the right, the time from the current observation, from the current row / document, the value we're currently seeing. And then it gets more interesting. We'll return the rolling average and rolling sum. So this is defined here in the first window block. So a window block always contains of the window definition. So kind of over which window frame do we want to aggregate the data. So in this case, it's a preceding and following document. So it basically, once we're in the middle of the document, this will always be contain like a window of 3 documents, and then our aggregate statement. So there we can say what we want to aggregate. So if we look at this, it would be our rolling average and our rolling sum, which is defined over this window. And then we can add a variable number of those window blocks. So for example, here's a second block. And this is basically just counting over all preceding values. And this is why we can do a cumulative sum of our values. So cumulative sum is basically all values we've seen before, whereas up here, the window is always like plus minus of what we're seeing here. Window operations, they actually support 2 kinds of observations. So what we've seen in the previous example is what we refer to as row-based observations, because we kind of like observe a number of results or documents, and then we aggregate over preceding and following ones. You already see, like, for example, here we are sorting by time. This is something very common that we want to analyze over a time aspect. So for example, how many sensors have failed within any given time frame. So you never want that you get more than 2 sensors failing within a 5-minute range, otherwise you'll sound an alert. And this is, for example, something you could implement here. This is something where we see people already implementing functionality you would typically more expect from like time series data stores. On the other hand, we got range-based aggregation. And this is actually being on a generic value and or a duration range. So for example, here, it's really just the number of rows you will see around it. So it's like 1 row before, 1 row after, whereas here we are talking about the values in it. So for example, we want to aggregate over t value, and for any current t value, so if we switch back here, for example, the value is 10. We want to take all values in the range from preceding 10, so 10 minus 10, 0, and following 5. So for that record where we see a t value of 10, we would actually want that entire window range for going anything from value going from 0 to 15. And with that, it's obvious that for any tuple, for any instantiation of value, we might see a different number of documents being accumulated here, whereas here it's actually always the same number of rows being aggregated, whereas here it really depends on what values are there and how many records have this value. What ArangoDB will do, it will actually implicit, if it's not done by yourself, add a sort on t value internally as an optimization, and leverage that. So it basically assumes that this will be sorted in terms of t value to evaluate it. Okay, so that was kind of what we have on the, let's call it analytics time series front of things. What we have in terms of graph is, as mentioned, the weighted traversals. And similar as the window queries, this is actually a community requested feature. And this is always great to see that our community is actually requesting features, but also helping us to implement that. So really proud of ArangoDB having a very open source community, very active, and a lot of contributors helping us to determine the roadmap, but also help to contribute to that roadmap. So weighted traversals, let's actually step back and see how was that before. So if we would do a traversal, we had 2 options, and that was either depth first search or breadth first search. And if you're familiar with algorithms, so it's typically some of those algorithms you would have to implement for your first IT job in that first interview, implement one of those algorithms. But basically, like depth first search first tries to explore a graph by, or connected data structure by like really going deep until it finds a leaf node, whereas breadth first search will just explore like first the neighborhood of one from the starting nodes and neighborhood of like 2 hops from it, and so on and so on. For a number of use cases, neither of those strategies, exploration strategies, is optimal, or might not be optimal. If it's just about correctness, you might use either of them, but in terms of efficiency, it will make a big difference when you use depth first search, when you use breadth first search, or when you now use the new option of weighted. So as mentioned, this is a community requested feature, and some of that motivation is that a lot of people wanted to implement a very custom shortest path or k-shortest path algorithm. So a k-shortest path, we want to find like a specific route between 2 nodes, and so some of them, they basically had a requirement that they wanted to find the shortest path to like any city bigger than 10,000 inhabitants or something like that, or filter across the passes on certain weights. So basically kind of like a very specific filter conditions on shortest path algorithms. And so for that, neither depth first search or breadth first search is going to be super efficient. And so what they did, they basically ran like k-shortest paths, found out all the k-shortest paths, and then filtered in the end. And what they now can do is they can basically explore that graph with ordered weighted. And this means if we look at a graph, for example, here, if we start at Berlin and we say we want to follow the weight attribute travel time here, we'll first explore the shortest one, and this is 400, and then we'll basically continue expanding always on the shortest path. In addition to that, I mean, if I would specify it like that, it's basically ends up being k-shortest path, but obviously here I can add filter statements, prune statements, and a lot of other functionality, or also just a very custom selection on my goal nodes rather than in k-shortest path or shortest path where I would have to specify a specific goal node. So it basically gives me a lot of flexibility in terms of graph traversals. Arango Search, as mentioned, Arango Search is our full text and retrieval engine. So it allows you to, from within ArangoDB, for example, combine a full text search together with then a graph traversal. So this is an example from the IMDb movie set. So first we want to find movies matching our sci-fi description. And then from there, we look up a certain metadata, director, movie, etc., etc. And this is actually a use case we see more and more coming up, both in our community, but also our customer side, is exactly that combination of search and graph. And this is also why we added a number of new features in this realm. So just to understand some of the terminology being involved, let's briefly talk about how this happens. So here on the right, we have our raw collections. This is what the ArangoDB term for basically tables in a relational database. This is where we store our core data. So documents, graphs are composed of collections, etc. Then Arango Search allows you to specify analyzers, and those analyzers will take data from collections and create views. So views is basically a derived form of data, and then the user can query those views. You can filter and rank them, and basically get results similar to, for example, Lucene or other full text search engines you're familiar with. What we added on the Arango Search side is, first of all, the pipeline analyzer. And that allows you/us to actually chain multiple analyzers together. So Arango Search offers already a number of predefined analyzers, such as ngram, stemming, etc. So a lot of things, especially in the natural language processing domain. But it also allows you to write custom analyzers. And especially on the custom analyzers, we also added like a nice feature in 3.8, and this is the Aql Analyzers. And this allows you to leverage the Arango query language to specify your own analyzers as well. But back to pipeline analyzers. Pipeline analyzers basically allow you to take individual analyzers and then form them into a chain. So for example, you might here have your raw text input, then take an AQL analyzer, and then actually take the standard n-gram analyzer at the end, and this is going to be your output. And this really makes composing your pipelines, reusing your also custom analyzers much, much easier. Then next, we have the GeoJSON support on Arango Search. So that comes in kind of two sides. First of all, there is the GeoJSON analyzer for indexing GeoJSON objects from within an analyzer and creating the respective view, and also the GeoPoint analyzer doing the same for coordinates. And then we have also the GeoSearch functions, so geo contains, geodistance, in range, and intersects. So those are, if you're familiar with the geo support in ArangoDB, those might seem familiar, but now they're actually exposed also on the Arango Search side, and Chris will actually show a demo of that in a bit later. With that, let's actually move to other features. Chris, by the way, about the questions, I'll try to answer the questions up front. If you want to pick up some of the questions already right now, feel free to answer them on the chat as well. Otherwise, we'll try to address all the questions here at the end. I just see them popping in. Really great. Keep on asking questions. So internally, so you won't really notice that if you're leveraging ArangoDB, except that it will get faster in terms of getting your shards in sync. So we are a distributed database. We have different shards, and we will replicate those shards across different nodes. So if one node fails, your cluster won't be down, your data is still there. But for that, we also have to deal with dynamic scenarios where, for example, one node cannot reach another node. So it might happen that a node is kind of trailing that information which is in the leader node. And so we introduced a new protocol, Merkle tree replication, which is, again, an interesting computer science algorithm, allowing us a much faster comparison where we are in sync and how to get in sync. So especially in those dynamic environments, such as Kubernetes, where things are just moving around, or where you have unstable network conditions, this will actually improve your getting in sync and therefore your cluster performance rather drastically. Also, where we did quite a bit, I think I saw like one question at the beginning about metrics as well. This is about monitoring. So already we have supported Prometheus compatible metrics for a while. But now we switched to V2. Actually, not much has changed. We added a bunch of new metrics, and just for some of them, we slightly changed the bucketing rules to follow official Graphana Prometheus guidelines. So there you should have a brief look. It's all in the changelog, what changed between V1 and V2. I said it's really mostly about adding new metrics, but some of them have a slight meaning, and it said it only covers the ones which actually involved in bucketing. With that, we also decided to make it easier for people to get started on those metrics. So we now have default Grafana dashboards, because simply if you look at all metrics, so this is all metrics we have, there's also a dashboard for that, but this won't be really helpful as you really get a lot of information. So we actually set together with users, customers, our own managed service team. And really, I try to come up with default Grafana dashboards for different personas. So for example, for DB admins, for Oasis customers, for our Oasis on-call, for normal database users, for app developers. And this is actually here in the repo. So those are a pretty good starting point, not to be overwhelmed by all metrics, but still see what is important for people to be there. As most things in ArangoDB, this is open source. So if you want to add something, if you're missing something, please open up an issue or directly a pull request if you want to. And also Metrics API is documented down here. So I think this is a really good starting point for kind of your default monitoring of ArangoDB. Okay, more. Of course, there's actually much more. So if you really want to dive into all the details, here are the release notes. But let's just point out some more highlights. So we started to invest more and more time into the UI and visualizer. You might have seen it wasn't like our focus for 3.5, 3.6, 3.7, we did a bit. So I'm really happy that now we also have more progress there and also more developers working on that. So expect to see more and more improvements also in 3.9 and upcoming releases. We enabled the default per query and global memory limit. So if you already followed the 3.7 release, we added some per query and global memory limits you could set manually. So basically, this query is only allowed to take up to that much memory. And also global memory limit, basically preventing you from exhausting all memory from the node. And with 3.8, we actually turned them on to very high, but still some defaults in the beginning. So this is something you might want to check out and potentially adjust. We feel it's much better than the no limit case before, but it's something you should check out if you're really running your server at very maximum memory capacity. We already talked about the metrics and dashboards. Also there in upcoming releases, more to come. We improved the performance of ArangoDump. So ArangoDump is, there are two backup solutions to ArangoDB. ArangoDump basically allows you to dump individual collections, as you might also know from like a SQL table where you can just dump an entire SQL table, but obviously on Arango side. And then on the other hand, there's the hot backup, which takes this consistent snapshot through an entire cluster. Hot backup is being an enterprise feature, just by the way. But we work quite a bit on improving the ArangoDump performance and also the restore performance. On the JavaScript security side, ArangoDB allows you to specify custom functions or also Fox services in JavaScript. For some environments, this might be some security risks. So we have some users running in constrained environments, healthcare, finance. And so for them, you can actually control how much JavaScript you kind of allow. So there's quite some fine granular scheme, and kind of the most extreme measure would be to turn off JavaScript entirely. We added Aql Bit Functions. Also, this has been a community requested feature, allowing you to do bit operations directly in AQL. We improved the sort performance. So whenever you use sort in any of your queries, you should see quite some improvement here. Reduce the agency memory consumption. So just in terms of notion, the agency is kind of our distributed brain. If you're familiar with etcd or Zookeeper, this is kind of our own Zookeeper variant. And we also enabled hardware acceleration where available for data on disk encryption. How to get started? As said, we pushed the release to first week of July, but please get the RC, get ready for testing, and give us feedback. This is really what's helping us from community side to make ArangoDB better and better. So also we have a number of interactive tutorials, so you don't even have to install ArangoDB. They're running against our managed service, and from there you can then basically test out certain features. Okay. With that, I would actually hand over to Chris here to show us ArangoDB 3.8 in action.
Excellent. Alrighty, thank you. And yeah, just back on the interactive tutorial side as well. Definitely check out the repository. We also have like a template notebook where if you had something you wanted to show off as well, it's really easy to get started with creating your own notebook that uses that temporary tutorial database that we have set up. So definitely feel free to check that out. And then for my part today, I'll be doing the demo part. I'm gonna go ahead and share my screen. So we're gonna be doing two just kind of short demos just to show off some of the stuff we've been talking about. The first one will be with Arango Search and the new Geo Analyzers. And then we'll take a quick look at some of the new metrics coming with the version 2 of our metrics and the Graphana dashboards you can get from that. So to start out, this is the just a documentation real quick. I wanted to take a quick look at, we've got the GeoJSON analyzer that is capable of taking in full GeoJSON objects. But then we also have a GeoPoint analyzer that is able to take in individual coordinates. So you don't need it to be formatted as a full GeoJSON object. And we also recently used this in our Arango BNB project, we called it. It's just a like a vacation rental clone. And so this has had a couple goals in mind. One of them was using the ArangoJS driver, showing an example of how to use that in a JavaScript full stack application, but then also we wanted to specifically have an example for our GeoJSON analyzer. So in this one, the rental properties have coordinates, which actually here is a running example of that. You can, of course, download that repo. We developed this project with some community members. They actually also developed a similar React front end at the same time that we were developing this Vue front end. So if you have any interest in Vue, React, or just trying to see an example of using ArangoJS in action, definitely be sure to check out this repository, and we'll send that around with the follow-up notes as well. But so the general idea behind the application is that we take a look at a map of, this is actually a map of Berlin, and we can click on individual markers here to get we can get more information about the rental. And you can do things such as apply filters to these things, for the amenities, room type, pricing, and then you can also do things like search. That'll bring up the markers. And this is going back and forth. The way that we're able to accomplish this is by grabbing this rectangle of the map and sending that through. And because all of the listings are indexed with an Arango search view, we're able to get them immediately sent back to us. And I wanted to quick show off the query that's involved in making all of this happen, as well as a query that actually one of our community members made to show off the individual neighborhoods. So here we've taken our analyzer and we're going to pass it through the rectangle, so that square space, and comparing it to, we're looking for listings located within our space, and we're using our Geo Analyzer. And we'll actually, after this, we'll take a look at how you set up an analyzer in Arango, and as well as how you can create a view. Just a really quick idea on kind of how easy it is to set that up, but then also what that looks like. And so here we go through and kind of filter out our room type. We have some preset values here just for this, and the same thing with amenities. and price, and then we actually end up sorting by reviews and score rating. And this is actually also a nice convenience of the Arango search view, because we're able to basically index the listings based on these attributes. So we get the sorting sort of for free. And then we also return the relevant amenities to those results, so that we're always getting amenities that are relevant to the results being displayed. And this will give us a bunch of listings, which is the equivalent of what we're seeing here when we click on one of these and then go in. It's this information that we're seeing here. So the other one that I wanted to show you has to do with neighborhoods. This information, which, by the way, we found this data set from inside Airbnb.com. So if you wanted to see the source data, definitely go ahead and check that out. There's also an article on the ArangoDB blog that I wrote regarding how we did some of the data modeling, how we got that info into ArangoDB, as it was, I think they were all just CSV files at the beginning. So definitely check that out if you're interested in kind of migrating over potentially from a different database, or you just have files that aren't, specifically perfectly structured for ArangoDB. The neighborhood search here is what I wanted to show. And so what this is doing is pulling neighborhood information. We have a collection here that just contains neighborhoods and their coordinates. And then we can do a search for that using, again, our this is actually a GeoJSON analyzer. And then that displays the neighborhood on the map.
I actually have to confess you, this was super helpful for me to learn the Berlin neighborhoods. So when I moved to Berlin, I had like no clue of the neighborhoods, but this was super helpful. Thanks, Chris.
Very cool. Yeah, so, and if you want to see this one kind of in action as well, this is a part of the React front end where they make it so you can click around on the actual map to help learn those neighborhoods and do things like start getting information for listings listed within those neighborhoods and that sort of thing. So the next thing I wanted to show real quick is I've just got like a test database set up here, and I wanted to show what it looks like to create an analyzer and then set that analyzer up on a view. So the first thing I will need to do is get our analyzers module. So this is exactly what you'll need to do. This is just doing it in the shell, but our drivers support adding analyzers, creating views, all of the above. So and so, for example, I think actually let's see what ones I have on here. Okay, do I already have my geo? I do have one already called geo, so I'll do another one. The analyzer is very simple for GeoJSON, so let's just call this Geodemo. And then we'll need to give it a type of GeoJSON. And the nice thing about the GeoJSON analyzer is the defaults are basically what you're always going to want to use. Oh, what did I do wrong? Oh, okay, I think it's wanting me to, there we go. Because we weren't doing any properties, it's just, I just needed to supply an empty property object there. But here are the default properties that I wanted to show. So with our JSON analyzer, we have a couple different types that it can be. It can be shape, centroid, or let me make sure I don't tell you anything wrong there, or point. And then these are the max S2 cells. And we even recommend leaving these, but if you want to get more involved, you can come and adjust these. But by default, the max cells is 20, min level 4, and max level 23. And that's what we're seeing here. And we did shape because we have a GeoJSON object, so that will fit that. And now that we've got this, we can take a look at our analyzers again. And here's our Geodemo Analyzer. So if we wanted to create a view and add this to it, I'm going to cheat a little bit on this part, just so we don't have to watch me write out all of the potential properties you can have for a view. The first thing you need is just a name for your view, and then the type. Right now, the only type that you would put in there is Arango search. I'm going to grab something from over here really quick. Okay, so all of this data is the view definition. Some of this is actually generated and you don't normally need to put it in. But for example, the kind of the most important stuff that you'd want to pay attention to is the links. With Arango search, you link collections to the view, and this is the process of sort of indexing your collection values. So the first thing that we wanted to index was our listings. And the fields that we indexed were the number of views. Most interestingly, we've got the amenities index. We're using our just normal text English analyzer there. Feel free to have a look at those. I'm not really going to go into detail on some of these other analyzers. But the one that I'm talking about now is this location field. And because our location field for our listings is a valid GeoJSON object, we could just process it as you saw, I already had one named Geo, but it's the same thing, a default GeoJSON analyzer accepting GeoJSON data. And once you pass all of this through, you can bring a number of other ones through. As many different collections as you want can go into one view, and you can decide what you want to do with individual fields for all of them. Or you can include all of the fields, which I did not do here, but you can do that with a default analyzer. And here's our neighborhoods, which is why the geometry of that neighborhood was able to be indexed and used. But the final thing that I wanted to mention was the primary sort. This is what I'm mentioning before, where we kind of get that sorting for free. We can actually specify that as you index your attributes, you want them to be sorted by specific values, and you can have multiple, so it will start with one and then sort by the other after that. So that's what we've done here. And I believe that should be all I need to do. And that will start going. This will take a while. This is basically indexing data, but as it does that, that's what I wanted to highlight is the really quick overview of creating a GeoJSON analyzer and then how you would use that in a Arango search view. And so if we were come back here, we could look at an example view here of what this looks like in the web UI. Once you've created your analyzers and linked everything, you can actually come here and make manipulations and add or remove different links or fields that you'd want to do. So that's just a quick overview of that. The last thing I wanted to show you is, actually this might be a good spot for questions. I don't know if I saw any pop up before I hop on to a different topic. In the ArangoDB, I am trying to understand that you below the. So yeah, so we are using OpenStreetMap for like getting the coordinates and everything exactly. And so we grab the coordinates. This application is actually using a library called Leaflet.js, and that is the actual map itself. But we do use the OpenStreetMap for the like tiling and location. So we grab that location information and pass it to ArangoDB, formatted as a rectangle or a polygon. So yeah. And if you'd like to kind of see a bit more, that's all available. Like I said, I'll share that repository to give maybe a better look at that. But yeah, we do use the OpenStreetMap API as well as Leaflet. Cool. Okay, so the last thing I want to take a look at, Jörg actually kind of already covered most of this. As he mentioned, not a lot has changed. We've just added a lot to our metrics and then restructured some of them to better align with how Prometheus says they should be. Something that I wanted to like mention at least was kind of how easy it is to set up some of these. This is from a guide that we were working on, but to get metrics set up, if you're using our Kubernetes operator, is as simple as enabling the metrics here. That's basically all you have to do to to enable them. Of course, there's always plenty of steps involved with doing deployment and all the fun involved there, but that can come down to being all that's required. Once you do that, you can have access to all of these metrics. So this dashboard is, we're just going to take a look at what some of the metrics look like. This has all of the available ones, but there are a number of more customized ones to fit. And of course, you can customize and make your own. You can start getting metrics such as,
just one short comment. Typically, I think this is all metrics is an overwhelm, so I wouldn't recommend anyone to get started with that. But this is a good good dashboard to see what is all available there.
Yeah, I doubt you'll be able to make use of all of these at once. It would just be, you'd want dashboards that basically just gave you the info you wanted right when you opened it up. But we do have a lot, so it's worth taking a look at them. As you can see, there's quite a number in each category even. So yeah, definitely could get overwhelming. And just a real quick some of the things would be, of course, of interest would be health and the heartbeat statistics is going to be probably important to a lot of people, being able to get access to that. And I thought also interesting, of course, is AQL, things such as memory usage, AQL queries, and looking at the times the query memory limit was reached, and these sorts of things that over time, and I know that the histogram for some of our metrics was specifically updated due to how Prometheus says they should be. So those things also now align better with the Prometheus specification. But yes, there's a number of AQL metrics that you can get. We won't look at all of these for that reason of there are so many of them. But looking at replication information, number of writes made, and just everything that you'd want to know regarding your cluster health and information, and yeah, just general network connectivity. Yeah, we won't really go into detail on all of these, but I did want to just kind of show you some of them working in action, and just let you know, I guess, have an idea of the potential for a lot of these metrics. So we've got various maintenance metrics as well. And if you do want to view all of the metrics that are available, check out the HTTP documentation. This lists the metrics, and we also have a good process for what it takes to set this up. And then we also have a repository available with some of these custom Grafana dashboards. And that is primarily what I wanted to cover. Let's see, we've got a question. Do you store the metrics shown in Prometheus actually in ArangoDB, as it will support the time series data, or do you use another type of storage?
We have an internal prototype, but currently we store them in Prometheus. So currently we just expose them, but yeah, we stay tuned.
Awesome.
Okay.
All right. Well, that is those are the two I wanted to cover, and yeah, like I said, I'll send around information with the webinar as well.
Cool.
Thanks.
Thanks so much. Then I will briefly take over and come to what we've been hinting at already multiple times, and that would be the last piece, what's coming up next. So kind of our roadmap. What we see a lot is kind of like GraphML and Graph Analytics. So we're pushing quite a bit in terms of more scalable graph algorithms, more scalable graph analytics, explorations into GraphML. So if you have any specific use cases, please reach out, because this will really help us to also shape the open source roadmap to match your request, your requirements. But yeah, in short, so what we have coming up is that soon, with a much smaller cycle, we'll release 3.9. So there's actually our time frame about sometime end of August or sometime August. And the key feature will actually be hybrid smart graphs. Those of you who know the enterprise features, we get smart graphs, basically smart sharding rules of the graph incorporated and supported by the query optimizer. And then we have satellite graphs and satellite collections, which allow you to replicate small metadata graphs, small metadata collections across the entire cluster. And in 3.9, we have an efficient combination of both, which is also supported by a set like the optimizer identifying those situations. We will add, I mean, you saw we added a lot of metrics. We will add improved alerting rules, a number of performance fixes not mentioned here, but also on the ML side of things, some early experiments on model inference. Then what we are really working on and pretty excited about is ArangoDB 4.0. So there we have a large number of features. So a kind of hidden feature in 3.8, which we shared with the community and customers, but don't call it an official feature, is a custom Pregel. So custom Pregel allows you to write your own Pregel algorithms on the fly for a running cluster. There's a separate webinar on that available if you're interested. So this will become GA. We'll work on trigger support. So this has been highly requested, similar as change feed, where you can basically alert on certain conditions in your cluster. From a cluster perspective, we'll optimize the replication even further. As said, this is a challenge we're seeing with more dynamic and also more and more growing clusters. So we just want to make it even faster for you. We're working towards this full support for distributed transactions. Currently, ArangoDB is supporting transactions in either single node or one shard deployments. And this is actually all together coined Cluster 4.0. On top of that, we're working on more ecosystem integrations, as for example, Spark, Kafka, and others, and also an updated version of our graph algorithms library. Beyond is kind of like our longer term roadmap, which we are still already looking into. And so there we have support for GQL, so the graph query language. It's kind of the upcoming standard for graph query languages. So similar as SQL is for relational databases. There's a consortium working of basically all graph database projects, graph database vendors, including us, in defining a standard. So I think this is going to be pretty exciting from a query perspective. With that, thank you so much for listening. Feel free to post more questions in the chat or reach out to us if you have any more questions. Take 3.8 for a spin, and really excited to have the GA release soon. Thanks very much for watching.
We do have a couple questions. Tim's wanting to know just more about our machine learning functionality.
Okay. Tim, as mentioned, feel free to reach out to me as well. I can share also another blog post. There should be a lunch and learn session. So we now have this format of lunch and learn sessions. So there's actually an overview of that, what we all do. But as said, like I think I shared my email with you earlier. So please just drop over an email. Happy to share more resources there.
Do we have any official plans for releasing an official driver for .NET?
Yes, we started working on that. So this is moving forward, probably either 3.9 or slightly after 3.9. So should be still Q3 when we have an official .NET driver. So we're basically working together with the community drivers and kind of will graduate one of them, and also so we added one engineer to our team to work on that.
Awesome. And finally, any new features for Fox?
So, I mean, you can call the JavaScript security features Fox related, but yes, in 4.0 we'll definitely, there's the V8 engine replacement, so we're working on making Fox even faster and safer. This is easier 4.0 or beyond, but there's definitely something on the roadmap because we still are pretty happy with Fox and also want to enable more use cases. If you have any user stories which you would like to do with Fox but currently can't, please reach out and let us know.
Yeah, I'll be happy to see new improvements to Fox as well. And actually, speaking of the Lunch and Learn, there will be a Fox Lunch and Learn session coming up as well. So if you're not familiar with it, keep an eye out for that. And yeah, if you have any cool user stories, we do have this, we call it the Community Pioneer program. And actually next week, the 30th, I think this next week, we'll be doing a Community Pioneer webinar with a community member that made a really cool project with ArangoDB. This can be this, he made this for like a dev challenge. He's still a student. So it doesn't have to be something that you're using live in production, but it's just something that we can share with the community that lets you show off a cool use case and lets the community learn more about ways to use that. So yeah, if you have any projects you'd like to share, reach out to me directly. I'm on the community Slack, chris.arangodb. You can reach me either just through our learn at ArangoDB, or myself, just christopher@arangodb.com. So yeah, definitely let me know on any stories you have there, and be sure to check out our Community Pioneer webinar. We have actually a couple coming up, but the next one is on the 30th.
Cool. Thank you so much again, and really looking forward to hearing more from you. Thanks, everyone.
Thanks.
Thanks, Chris.